Okay, the screen's big enough, that's for sure. Okay, very quickly, just to, this is my 20th year teaching agricultural science, biology and junior science. And as you're all aware, the new specification for ag science was released very recently. Now, just to give you a little background on the old syllabus. The old syllabus was released in 1972, a year before we joined the European Commission at the time. And obviously agriculture had changed an awful lot since then. The old syllabus was 5 pages long. And it actually made some of our learning outcomes based specifications seem detailed. It was incredibly vague. There was obviously no depth treatment. And ultimately what became the syllabus was the only available textbook that was there. That was driven, in terms of its additions, by the assessment criteria, the assessment exams. So it was the absolute perfect epitome of the old adage, the assessment dog wagging the curriculum tail. The new syllabus was built on a draft specification which was published in 2016 after 2015 background paper. There was a full consultation with teachers, and the final specification was published in January of last year. The first PDST training began last March, and then after one training session, it was implemented in the classroom last September. A second PDST training day took place in October 2019, and the third one is due in March. This diagram kind of gives a really good overview, actually, of the course. You can see that it's central. There's 4 strands. The central strand is scientific practice, and then there are 3 main strands around that: soils, animal production, and crop production. And then, as you see on the outside, then these are 8 cross-cutting themes that link in with each of the different strands as well. So what have been the welcome changes? And there have been welcome changes, absolutely. First of all, I think it's really, really positive that we have a far greater focus on scientific practices within agricultural science. It was so important that the new specification, when it came out, was going to ensure that agricultural science remained a laboratory subject. It was the first introduction of mandatory investigations, which there are now 20. In the time since I've been teaching agricultural science, over 50 experiments have been questioned within the leaving certificate examination. The old textbook had 202 experiments within it. So it really was a lottery in terms of what you could be asked within the examination. And there was a dedicated question on the paper to experiments. But now we have 20 mandatory experiments, 11 of those within soil science. But I think there's really good scope for most of them for an inquiry-based, certainly an instruction-based approach to, I suppose, use that nature of science, scientific practice element of the specification. There is a far deeper emphasis on technology, genetics and genomics, sustainability and safe working practices, which really, in a lot of cases, didn't exist at all when the old syllabus was released in 1972. So that's really very welcome. There's been introduction of agricultural policy and economics within the main agricultural science specification. And this has meant the discontinuation of the older course, agricultural economics. And there's been some removal of the overlap between leaving cert biology and leaving cert geography, which I think is important. And there's been changes to the practical assessment component of the course as well, which I think was welcome. I think there was definitely issues with the old practical component. Some of the challenging changes have been some of the following. So it is written using broad learning outcomes. It's got 91 learning outcomes in total. The learning outcomes are spread over 9 pages, give you an indication of the depth. They do lack depth of treatment, and I'll show some examples in a moment of how they do so. Interestingly, after the draft specification was published, 13 new learning outcomes were introduced to the final specification, and there were minor changes then to several others. The mandatory practicals are embedded within the learning outcomes. So 91 of those learning outcomes or 20 of the 91 are the actual mandatory practicals. And there was one new mandatory practical introduced in the final specification as well without consultation. I think the biggest challenge so far actually has been how inefficient and actually how poorly planned and delivered training has been. And I'll talk a little bit more about that later on. But that has been a really big issue for me. It hasn't really addressed some of the fundamental elements that we need as teachers to deliver new specification. It has really focused so much on curriculum planning and unpacking those learning outcomes that actually there's been no input whatsoever on methodologies, use of technology, no training on the mandatory practicals, no training on the assessments elements. And teachers are floundering in a fog, which was used earlier on, I think, really trying to see how they actually can implement the course, because it's all been focused on planning. I'm just going to expand on a few of those challenges a little bit. Just to give you some examples, these are all ones within the nature of science strand. And actually, I think all of these are very commendable. I think this is probably the strongest area within the specifications. All of these, I think, as a teacher, are easy to implement. It's easy to design. This one, for example, is describe the factors involved in soil formation. So the question must be asked, well, what factors? In fact, actually, what soil? So teachers are wondering, what do we include? What don't we include? There's another one within the soil section. Appreciate the importance of the rhizosphere and the relationship between soil fungi and roots and the impact of that relationship on productivity. So it's very difficult to assess appreciation. I'm going to come back to that a little bit later on as well. I think it's really, really important element, but again, the depth of treatment here could be either really, really substantial, or it could be quite minimal. And then there's this one. Unpack that one. Genuinely, I wouldn't know where to start to unpack that, and certainly I wouldn't know where to end. I'll let you read that. I think we've got time. Now, when the draft specification came out, I was part of a group of members of the Irish Agricultural Science Association who met with the NCCA and submitted information back. And we pointed out this learning outcome was incredibly too detailed and it needed to be divided up into smaller sections. They actually added extra bits and pieces in the final. They added the elements about carbon sequestration. A couple of more examples. What are the main parts of the plant? Are they the leaf, the stem, the roots? Are we talking about cells? Are we talking about specific cell types? With regards to those processes, this is the only mention of them within the specification. So how much detail do we have to go into photosynthesis, or respiration, or transport, or transpiration, or nutrient absorption? Now, surely if you want to address structure to function, you're going to need to be aware of the function. You're really aware of those processes in detail, and we have no idea what depth of treatment we need to apply to those. This is another very interesting one. Understand the principles of genetic engineering. Now, to understand the principles of genetic engineering, you need to understand the principles of DNA. DNA is not mentioned within the specifications. The cell is not mentioned within the specifications. And if you're talking about how genes produce proteins, you need fundamental information about protein synthesis to a degree, and certainly how DNA translates to RNA and so on. And this is another one, discuss strategies for crop protection against diseases. Well, which diseases? Which strategies? Here are a selection of various different ones that all begin with appreciate. Now, 9 of the 91, just under 10% of the learning outcomes begin with the word appreciate. So as a teacher, it's very, very difficult then to say, right, okay, how am I going to unpack these, if that's the term we want to use, in order to kind of create engaging activities that are measurable for the teacher. So I can actually say, right, I know this person has achieved to the requirements of the specification. Now, the NCCA's solution to depth of treatment is to provide action verbs. I just want to show you some of the action verbs here, and I want you to highlight appreciate for a second. Recognize the meaning of, or have a practical understanding of. Now, which is it? Now, if we go back to those again, if I want to recognize the meaning of compliance in relation to notifiable diseases, that's fine. But if I want to have a practical understanding of compliance in relation to notifiable diseases, that's a very, very different state of affairs. we have to unpack these learning outcomes. And I think we have an unfair burden of responsibility placed on us to design the curriculum. And the more time we devote to this, the less time we have to design meaningful, engaging activities to deliver the specification. It is a breeding ground for inconsistency. And ultimately, I think it's actually going to bring us right back to where we started, because the examinations are going to be what defines depth treatment. And we're going to end up in exactly the same position we were before, with the assessment dog wagging the curriculum tail. Ultimately, I think we end up with an inferior curriculum. And I saw this quote earlier during the week when I was reading a piece by David Dido, and he says, the quality of teaching will struggle to exceed the quality of the curriculum. If you have an inferior curriculum, no matter how good your teachers are, no matter how committed they are, no matter how well-meaning they are, they're going to struggle to outcompete a poor curriculum. So that's learning outcomes. On the mandatory practical activities, just to give you some examples of these, here are two soil ones and one plant activity. Actually, I think these are really nice. And I think the vagueness actually here is quite good to a degree, because it means that pupils come up with their own hypothesis, they can come up with their own procedures, and they're free to kind of go down whatever route they want to as well. So I think it's really, actually, I think the mandatory practicals are a really good addition to the specification. This is one though that I have a severe problem with. Let you read that for a second. This mandatory practical was introduced into the final specification without consultation. It appeared out of nowhere. There's been no training whatsoever on the mandatory practicals. I have no idea where to start. I've contacted Shaw's, say, can I get plants that can be bred quickly, that can be hybridized, that have straightforward gene patterns that we can do, and they're at a loss. The best they can offer are plants that they might have available in 9 months' time. The practical assessment component has been replaced by an individual assessment investigative study. And actually, in all intents and purposes, it's a mixture of CBA1 and CBA2 within the junior cycle. So, I think actually I'm willing to reserve judgment this. I'm actually quite excited about implementing this in the classroom, to be honest. Pupils basically, as you can see from the bottom, they have to develop a research question, they have to carry out research, extensive research within the literature on that. They then must carry out experiments to support the research and gather the data and present it in a pro forma report, which is 2,500 words. So I'm actually really looking forward to getting stuck into this. The big problem with this has been training. As I said, it's been delayed by 7 months really. So already the current cohort of 4 and 5 pupils are really, minimum 3 months behind. But in reality, teachers really are going to wait till they get formal training on this. They're 7 months behind. I'm not one to gripe and not offer solutions. I don't like being a mouthpiece. So I think there are solutions here. I think the very first one is that there needs to be full and comprehensive teacher guidelines required to address this significant issue of depth treatment. I mentioned earlier on that I was part of a small delegation from IASTA to meet with the NCCA during the consultation of draft specifications. And we met with Bill Lynch in Portlaoise. At that meeting, Bill told us to not worry about the vagueness of the learning outcomes, that the NCCA would be publishing detailed teacher guidelines to deal with the depth treatment. Now, I think actually Bill genuinely thought that, but of course they have not materialized, and I don't think they will materialize. I think we need to receive comprehensive training on the practical activities, provide us with suggested procedures, equipment, and chemical requirements. We need to give far greater resources to the PDSD if we think that they are the body who should be administering training, and there should be far greater levels of accountability. I think one thing we can definitely all agree on is that the JCT team, JCT for Teachers team, was incredibly well resourced. And I think that same level of resources need to go into the PDSD. This is a subject where 14% of the pupils in Leaving Cert are doing. It's the same as physics. It's a little bit less than chemistry. So we need to resource this. I think we need to shift away from this non-linear approach. There's no evidence base, and every feedback I've got from teachers is that they need support. And I think there needs to be greater clarity on the implementation of the practical assessment component of the 2020 brief. So finally, what my advice for the NCCA would be, for what it's worth, would be to abandon a similar learning outcomes model for the use of biology, chemistry, and physics, because the same mistakes will happen. Remove the burden and responsibility for teachers to design the curriculum. As I said, it will just go back to the same situation where we have the assessment dog wagging the curriculum tail. There needs to be a sufficient time for a full consultation period for new specifications. To listen to teachers, to listen to the Hyden report. Even the NCCA published their report on the background papers last night. In it, there's loads of evidence from teachers to show that they don't want this same system and adhere to international best practice. Use evidence-informed approaches to curriculum design and promote evidence-informed methodologies to implement specifications. And finally, I think to create a senior cycle support service equivalent to the JCT for teachers to provide them with sufficient resources, early training interventions, and resources for teachers. Thanks very much.